Hello, everyone. I just want to welcome everyone to migrating from OpenSSL to wolfSSL. Before we begin, I just want to remind everyone that you can follow us at all of our socials, which is at wolfSSL on Twitter, Instagram, Reddit, if you so choose to. And then if you have any more questions, you can also email us at info@wolfSSL.com. And now I'm going to introduce our senior engineer, Jacob Barthelme, who will be talking more on the matter.
Thank you. Hello. Today I'll be covering a bit about the wolfSSL compatibility layer. I'll be going over the four main topics of what is the wolfSSL compatibility layer, building wolfSSL with the compatibility layer enabled, a simple example application demonstrating its use, and examples of major projects that the feature has been used in. First, a little bit about wolfSSL. It is a software library that provides cryptography primitives as well as an implementation of the TLS protocol. The code is dual licensed as GPL v2 on our GitHub repository and main website download page, and can be acquired under a commercial license also for commercial use cases. The library is used in many projects and is currently securing over 2 billion connections around the world, ranging all the way from IoT embedded connections up to large server farms. wolfSSL meets demanding standards for security, including FIPS certification, DO-178, and has an extensive testing system. With the library being built with resource usage in mind, it has a smaller footprint size than most, and also has build options for increased performance. wolfSSL has many features that it provides, one of those being the wolfSSL compatibility layer. This feature provides a means for making calls to OpenSSL API functions, but with having the wolfSSL native implementation be used instead. With the use of macros, it maps a subset of OpenSSL APIs down to wolfSSL's native APIs. The compatibility layer is constantly getting expanded as new projects get completed, and there's currently more than 500 of the most commonly used OpenSSL APIs supported. In addition to mapping functions, there's also support for a subset of structures and common enums. An example of a few of the crypto APIs supported would be implementations for EVP and bio. Covering a bit more about the crypto API supported, there's support for EVP init, update, and final function calls. In addition to the init, update, and final functions, there is signing and verifying EVP API available. These EVP functions mentioned are abstracted functions that OpenSSL uses for many different underlying algorithms, such as performing an RSA signature operation or doing AES encryption. There is additionally support for direct calls to hashing algorithms like the function SHA and SHA-256, along with support for direct calls to AES encryption and decryption. The P key structures are supported to help with using the crypto and X509 API mapped to by the compatibility layer. This allows for loading in and working with keys using an unaltered application that was previously linked to OpenSSL. The problem that the compatibility layer solves with having all of these APIs and structures mapped is to allow for easily migrating from OpenSSL to wolfSSL. This is with having an unaltered application that was previously linked to OpenSSL and migrating it to wolfSSL by only updating link and include paths. Here's a brief snapshot of the main header for the wolfSSL compatibility layer. It shows places where the names of the OpenSSL structures get mapped to wolfSSL implementations. It also shows a couple of the main TLS API mappings. The bulk of the code mapping APIs will be located in this SSL.h file. Before getting into the example application and how to build wolfSSL for use with the compatibility layer, I'd like to cover why someone would want to turn on the compatibility layer feature and why they may want to migrate from OpenSSL to wolfSSL. There are many reasons for wanting to make this migration. I've listed out some of them on this slide. One reason is that there is a lot of hardware acceleration ports that wolfSSL offers, from the usual ARM assembly or Intel AES-NI, all the way down to embedded uses like the Freescale MMCAU. Another point of interest to many is the addition of progressive algorithms in the early adoption of TLS 1.3. Also, with the reduced footprint size of wolfSSL, users are able to reduce the number of resources dedicated to TLS connections. Later on with an example I have on the slide, I will show just how much the heap size can be reduced by migrating to wolfSSL. A couple other examples for the reasons for the migration, maybe for the FIPS code offered by wolfSSL, or to get support from engineers who work with and wrote the code, or because of the clear licensing model offered when using it in projects. Soon there will be a lapse in coverage for OpenSSL FIPS projects. OpenSSL is expected to drop to the historical list in 2020 and not have a new module available for FIPS until 2021. With the wolfSSL compatibility layer, it is easy to plug the library into a project that may be affected by this lapse, keeping the project up to standards and possible requirements. In addition to maintaining FIPS support, wolfSSL has a FIPS ready build that helps with getting projects ready for FIPS validation. This FIPS ready build lets users run a code base very similar, if not the exact same, as what would be put through the labs for certification. That covers the basics for what the wolfSSL compatibility layer is and its value when used with a project. Next is going through the steps of turning on the feature when building the library. To build with the compatibility layer enabled, when using auto tools, the flag enable OpenSSL extra can be used. In addition to the OpenSSL extra flag, there is also an OpenSSL all flag. OpenSSL all enables a superset of implemented functions by including some of the API implemented when expanding for use with new open source projects. If building in an IDE or cases where auto tools is not being used, then the macro OpenSSL_extra can be defined. This macro can either be passed by a preprocessor flag, or better yet, it can be set in a user_settings.h file. When linking against the wolfSSL library and having built using auto tools, the file wolfSSL/options.h should be included. This should be included as the first header that are used from wolfSSL. This is to make sure that the application is using the same settings as what the library was built with. All header files needed for migrating an application over to wolfSSL are located in the directory wolfSSL OpenSSL. An example of that would be that SSL.h file we looked at before, the wolfSSL OpenSSL SSL.h. With the internal behavior of wolfSSL being different than OpenSSL, there is some cases where only subfunctions were needed in projects. These are functions that allowed for compiling the code, but do not actually do anything when called. It's also the case that when migrating some projects over to wolfSSL, the features were not needed, so the functions were not finished at that time. It can be useful to tell whether your application is calling a stub function or not. To help with that, either the debug feature can be turned on with enable debug, or the macro no underscore wolfSSL underscore stub can be defined. Turning on the debug prints out a warning message each time a stub function is called. And defining the no wolfSSL stub macro will throw compile time errors if the application is attempting to use any stub functions. wolfSSL is a very modular library in how it can be built and configured. The enable OpenSSL extra gives a default build, but with it, wolfSSL being very modular, there may be some other additional features that are required by the project. One example is if you're doing key generations, you'd want to do add enable -keygen to the configuration. That covers the basics for how to build the wolfSSL library in preparation for the Great Migration. The next items are covering how to use the library once built and example cases of projects that the feature has been used in. When migrating an application from OpenSSL to wolfSSL, one of the things that needs to be resolved is including the right header files. OpenSSL headers should no longer be used, and the header files located in wolfSSL should be used instead. This is typically achieved in one of two ways. Either with changing the preprocessor include path to point to the wolfSSL directory with the OpenSSL compatibility header files, or by changing the application code to have wolfSSL prepended to the includes. In most projects, we opt for the first option because it does not require any code changes in the application and is done by simply adding a preprocessor flag when compiling. The next thing that needs to be updated when migrating a project over is the library that it is linking to. When an application is linked against OpenSSL, -SSL, -SSL, and -L crypto are used. This should be changed to be -L wolfSSL so that the application is now linking with the wolfSSL library instead of OpenSSL. It's as simple as that. After the migration is complete, after changing the include path and changing the library it's linked to. Here are two examples of altering the include path and library linked to. The source file of the Great Migration is a simple TLS server written for this demonstration that uses OpenSSL API. The first example command line executed has the application using OpenSSL headers and linking to the OpenSSL library. The second command line executed shows updating the include path to point to the wolfSSL directory where wolfSSL headers are. In addition to adding the include path, I also use the -include flag, which tells the compiler to include wolfSSL options.h as the first include file when compiling any source codes. And finally, to have the application linked to the wolfSSL library created, the links to SSL and crypto were changed to wolfSSL. From executing each of these commands, executable was created, open.out for the OpenSSL version and wolf.out for the wolfSSL version. The slide shows a small code snippet of the example TLS server used. It shows about the bulk of the TLS code after a certificate has already been loaded and the client has initiated the TCP connection. In the code, only OpenSSL API was used, which when using the wolfSSL compatibility layer gets mapped to the wolfSSL native API. This just shows that the example could be compiled without altering any of the code. This slide highlights the difference in heap used with different builds for each of the libraries. Well, excuse me, with default builds for each of the libraries. To collect the heap usage, I built the application on Ubuntu 18.04 and use Valgrind's massive tool. Then to make the pretty graphs of the outputs, I used a massive visualization. In both cases, the cipher suite used was ECDHE, RSA, AES-256, GCM with SHA-384. This is pretty much the standard default cipher suite for both of the default builds. And the same client was used to connect to both servers. With using OpenSSL version 1.1.1, the peak heap used during the connection was 202.1 kilobytes. When taking the same example server and linking it against wolfSSL version 4.1.0, the peak heap used was 42.1 kilobytes. Each of these examples was with the default builds. wolfSSL also has some optimizations that can be set for reducing the amount of resources even more, getting the heap usage for the same cipher suite down to around 22 kilobytes. And both of these were with that the Great Migration.c, the example TLS server that I showed in the previous two slides, just linking against OpenSSL versus linking against wolfSSL. That covers an example of using the compatibility layer and the resource use reductions. The final item to cover is examples of major projects used in and determining if all APIs needed for migration of your project are available.
Okay, before we continue, I have two questions for you.
Sure.
One of them is, do you have a programming style guide that you use? And if so, what is it?
We do have internal coding standards that we keep to. A lot of those are making it so that our library is close to uniform as possible, and we also have like spacing requirements. I'm not sure if they're talking about MIS or C. That's another like rule guidelines for coding. We've done some with MIS or C, and we're actively altering some of our source code to follow that one.
Alrighty, and then another question we have is, do you have a call tree document?
I don't think that there's a call tree document up on our website. If there's interest in the call tree document, that's something that we could see about getting up on our website. What we have right now is mainly a list of APIs, and then we have our default examples up on our examples repository that someone can download and see which APIs to use.
Alrighty, and that's it for now. Thank you.
On this slide, there's a list of some of the major projects that the compatibility layer has been used in. Some of the recent additions that we've done is the Apache builds, and we've also done with the Qt build. We did Nginx a while ago, and we've been maintaining it. And we have a build with wolfSSL and the MySQL. That's shipped with MySQL, the newer versions. And then we've been built with curl and stunnel. There's also quite a few that aren't listed in this that we've compiled in with the compatibility layer. If you have an open source project that you're interested in using wolfSSL, and you can contact us and we can see if we've done it before or scope out what would be needed. For many of the major open source projects that we port to with the compatibility layer, there is an associated enable option. This is to guarantee that all features used by the open source project are enabled when wolfSSL is compiled. An example of this would be with enable Nginx or enable HA proxy. This is going back to where wolfSSL is very modular. If Nginx is expecting like key generation to be on, this would take, for example, this would take care of auto enabling key generation so that wolfSSL can be used with Nginx. The full changes done to our engine, to Nginx can be seen on our GitHub repository. We have quite a few of our open source ports up on our wolfSSL GitHub repository. With the compatibility layer being a subset of all possible OpenSSL API, there is a chance that some API used in your application may not yet be implemented. The easiest way to tell if there are some missing gaps in implemented API is to compile the application with linking against wolfSSL. This will list out compile time errors for all unimplemented functions. If it is found that any API are missing, we do accept like feature requests, or we accept code contributions. In addition to that, we offer consulting for expanding the compatibility layer as needed for the project, if it is required. That gives a summary of what the wolfSSL compatibility layer is, why it would be used, and example cases. And at this time, we're going to open up the floor to any other questions that there may be.
We have a few more questions that were asked during the Q&A. One of them is, if MISRA is not checked, does Cert C get checked instead?
I'm not 100% sure about the Cert C. It's something that we could set up a technical call about to make sure that I get the right answer for you, because I'm not as familiar with Cert C as I am with MISRA C.
Awesome. Another question is, do you suggest using the compatibility layer if starting a completely new project?
If starting a completely new project, I would suggest using wolfSSL native APIs. Just because you can get slightly smaller memory usage if you don't have to have all of the mappings.
Awesome. Another question is, could this be used to, I guess, devices that communicate on serial communication without flow controls like CSMA/CD?
Okay. If I understand the question correctly, is this asking about like the transport medium? And if that's the case, then yes, wolfSSL is agnostic to the transport medium. We have a couple of IO callbacks, which can be used to communicate across serial connections. One example is we've been used on like a USB that gets plugged into a machine. It can do a TLS connection across that. We've done TLS connections across Bluetooth or versions of TLS across Bluetooth and as well as serial connections.
Okay. Another question we have is, does hardware acceleration support rely on crypto framework in Linux through /dev/crypto devices?
Yeah. So Linux does have their kernel drivers to be able to get the crypto acceleration. We have a tie-in for that if a user so desires to do that, but our AES can be used separate of that. We have some assembly that calls down for like the AES&I, for example. A lot of our crypto doesn't, our hardware acceleration is handwritten assembly or calls down to like a lower level API on some of our embedded stuff like the MMCAU.
Okay. Does the wolfSSL OpenSSL include does the wolfSSL/OpenSSL include directory contain OpenSSL compatible files such as x509.h?
Yes, the short answer to that is yes. Each time we compile a new open source project, we try not to change any of the include paths for the headers that it was previously included. So if required, sometimes we have just like I guess you could consider it a stub header file but we do have the header file there so that the code is able to compile without changing those include paths or include files.
Okay, does wolfSSL have auto SAR in interfaces to make it easier to use the automotive domain?
Autos are.
Or,
We have a project in the works. I guess that's all I think I can say about it at this moment is we have a project in the works for that, but it's possibly not going to be all of the stuff that's required for the project for the person who's asking. So that would be a good one to follow up on and see exactly which API the person who's asking for is looking for.
okay, and then does runtime performance compare this person's tests AES-CBC encryption/decryptions are showing runtime slower than OpenSSL 1.0.2 on x86_64 Linux and 20 times slower on their ARM platforms. Are there compile optimizations not enabled by default?
Yes, so OpenSSL by default enables a lot of their hardware acceleration. We have a couple of enable options that have to be turned on to enable the hardware acceleration. So comparing the default builds of wolfSSL versus OpenSSL is not